In this video, we're going to cover exam-style questions on isomerism, and this is part 2, and you should have hopefully gone through part 1 already. We're going to talk about functional group isomers, and we're going to talk about some naming, and it's really important in this one you make it active. There's plenty of opportunity for you to stop, do the work, and then put the video back on, so please do that. So the skeletal formula of 4 molecules is shown below. Look quite complicated, and I want to know which pair are structural isomers. Structural isomers are the same molecular formula, different structural formula. So 2 of these have the same molecular formula. It's very obvious that they are different structural formulas. So the first way of doing this, which is the most common way for students to do it, is just to do one of 2 things. One, draw them out in displayed formula and then count all of the carbons and hydrogens. That takes ages. Okay, and in exams, you don't often have ages to do that. The second way is to do it via the skeletal and just go, look, okay, there's 3 hydrogens there, there's 2 there, there's 1 there, and count them all around and do it on absolutely everyone. And again, I encourage you, stop the video, do that if you would like. I'm now going to go through a slightly quicker way of doing it. So there, again, to the side, I'm going to look for these pairs of molecules. So first of all, we have some functional groups here. We've got an alcohol, we've got an aldehyde. Okay, so over here, this is your aldehyde. Alcohol, aldehyde, are they functional group isomers of each other? No, they're not. Okay. Next thing is, there's another alcohol, well, that's similar to this, and then we've got this, which looks very much like an ether. It has a special term for this, but it's, for now, let's just think of it, oh, it looks like an ether, so let's do that. Now, that's the first thing I would look at. And then, as well, at the same time, I might go around and count the carbons. Because if they don't have the same number of carbons, that's a really easy check, first of all. And you'll find that this one right here has 1 less carbon than the rest. Every other one has 8 carbons. This has less. It has 7 carbons. Now, if that is the case, I can discount this one straight away. So that one is gone. So that is not my answer. So we're going to get rid of that one. Now, let's look at the quick way of doing the rest and look at some functional group isomers. So alcohols and ethers are functional group isomers, and they have the general formula CnH2n plus 2O. Now, these are, this is alcohol and a type of ether, and so they theoretically should have the same molecular formula, but they're a bit complicated, these molecules. We can't just take that into account. Let's take the next one into account. An alkene and a cycloalkane, CnH2n. I'm just reminding you of the alkene. We have no alkenes here, but you look at that and you can see CnH2n. Okay, they roughly have the same general formula. Well, this is a cyclo, and this is a cyclo. So both of them have a cyclo, which is the same type of functional group, essentially. And they have an ether and an alcohol, which is the same type of functional group conversion here, so functional group isomers. So if we make an educated guess very quickly, we'd say it's these 2, because an aldehyde, functional group isomer, is a ketone. There's no ketones here. So I'm going to make a bit of a guess here, and hopefully you're at home and you have decided to actually draw it out and check that I'm right, which I am. So if we then look at this and we go, right, here we have, count the carbons. So we'll go from here, let's do it properly. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, got this one, there's 6 in the hexagon, 7, 8. Okay, so it makes sense. That carbons are absolutely right. And then we go for the hydrogens. There's 3 there, 2, so that's 5. 1 on there, 6, 1 on there, 7, 3 on there, so that's 10, and then that's 11, 12, 13, 14, 15, 16, so 16. So I've counted all the hydrogens on there, 16. Have to go over here, let's count the hydrogens on here. This is a bit more simple. So 3 on there, 1 on there, so that's 4, 5, 6, and then the rest have 2 on, so 6, 8, 10, 12, 14, 16. So yes, it does have 16. So I could count it all like this, or I could look at the functional group isomers and see whether they have the type same type of functional group. Let's not forget the O. Okay, and then you have these two, which are going to be your pair of molecules, same molecular formula, different structural formula. Our next question talks about C7H14O. It wants you to know the structural isomers by comparing it to names. And it wants you to be able to work out the molecular formula, because you want the same molecular formula, because that's a structural isomer. Okay, and looking at each one of these and just applying it and see whether you can get C7H14O. There's a quick way of doing it and there's a slow way of doing it. The slow way of doing it is drawing all of them out, counting every carbon, counting every hydrogen. The quick way of doing it is to look at the general formulas of each one of these functional groups. And we'll do both. So let's put this over to the side. And then look at this here. Now the first thing I want you to look at is the fact that you've got an alcohol here. So you've got an alcohol here, and you've got a ketone here, and you've got an al here, which is an aldehyde. So if you haven't looked up those functional groups, you're going to need to for this video. So if we look at an alcohol, and we start drawing out the alcohol, your alcohol, if you know the general formula is CnH2n plus 2n plus 2O. So CnH2n plus 2O. Now if it's CnH2n plus 2O, you can apply it to that and just say, do you know, does that fit? Because the first one's an alcohol, so if it doesn't fit, then one is wrong. So therefore, is this CnH2n plus 2? Now let's have a look at it. It is Cn, and the n is 7. 7 times 2 is 14, so therefore it's 2n, and then O. So this is CnH2nO, this is CnH2n plus 2O for an alcohol, and this is an alcohol. Therefore, number 1 is absolutely wrong. Okay, so we know 1 is wrong straight away. We can then do another check and just count number of carbons just to make sure that the carbons are in line with 7. So that's 5 carbons, pentan, 2 methyls, so that's 2 times 1, so that's 7, and then ethyl is 2, pent is 5. So they both have 7 carbons. So they fit with the 7. Okay, we didn't even need to look at the 7 for the first one because those general formulas don't match. So the alcohol is definitely wrong. Right, if we then look at this and we look at the other 2 functional groups, which is ketone. So we're going to go ketone and we're going to go aldehyde. Now I've drawn them like this, right next to each other, because actually what they are functional group isomers. So if you haven't come across this already, they are functional group isomers. Okay, so they're functional group isomers. That means if they're isomers, they'll have the same general formula. And the general formula of a ketone or an aldehyde is in fact CnH2nO. Now if that is the case, and you knew that before you went to the question, you could quickly go, do you know what, that fits CnH2nO. So therefore my right answers are going to be number 2 and number 3, because they're a ketone, there's an aldehyde, they both have the right number of carbons, so they're going to follow that general formula, and they're going to be right. Now, the other way of doing it, just to prove we are correct here, is to say, well, let's look at the actual structures here. So C7H14, the first one is 3-methyl hexane 1R. I just want to prove one of them to you to prove we are correct. 1, 2, 3, 4, 5, 6. There's the hexane, and then the 1-ol. There's the 1-ol, and it says 3-methyl. So 1, 2, and then 3. And there you go. There's your 3-methyl hexane 1-ol. I just want to prove that this is correct. Now, if that's the case, and you count your number of hydrogens, you know the carbons are the same because it's methyl and a hex, which is 6 plus 1, which is 7. But if we look here, we count our hydrogens, so start there, 1, and then there's 2 hydrogens here, so 2, 3, 4, 5. There's 1 on here, so it's 6. So we've got 6 hydrogens so far. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've counted 16 hydrogens there. Again, stop the video, do it yourself, draw it out and display it if you want. There are 16. So the formula of this is C7H16O, which you'll find fits CnH2n plus 2O, which doesn't fit C7H14O. So therefore, definitely the alkyl again is wrong. I'm going to draw the 3-ethyl pentanal because I know they're functional groups of each other. But the easiest one to draw is the 3-ethyl pentanal. So what I'm going to do is, there's your pent. It says 3-ethyl pentanal, so 1, 2, and then the 3, and then there's an ethyl, 2 coming off, and that says pentanal. So there's my aldehyde that I've drawn on. I've got my aldehyde drawn on, I've got all of this. I just want to prove that this is correct again. Again, once I've proved it, hopefully, obviously you believe me anyway, but once I've proved it, you can see you can just do the short version here. And let's count the hydrogens. So 1 there. Remember, all carbons have 4 bonds. That's how we're doing this. 1 there, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we've got 14 hydrogens on there. So that's C7H14, and then not forgetting that O. And so our answer is 2 and 3. But you don't have to do it in this long-winded way, in this long way. You can just do it the short general formula way. Our last question is on a newly introduced functional group, and that functional group is alkynes. Now they can introduce a new functional group if they give you enough information. So here is the alkynes and the names. C ends in Y-N-E, and they give you the structural formula here showing that it has a triple bond, and also give you the molecular formula. So we have to do 3 things: suggest the general formula, do the structures as 2 structural isomers, and draw the structure of a new alkyne. And we can work that out all from the table. And they've done this with ethers and done this with alkynes, but we've talked about ethers in earlier videos. So now is alkyne's turn. Right. So if we move on and do the first part. So the first part is about the general formula. So the general formula, I would suggest that when you're doing, when it comes to organic general formulas, base it all on CnH2n. So CnH2n, think about it, C5, 5 times 2 is 10. How do I get to 8? Well, I can take away 2 from 2n, okay, and that works. Let's go to C6H10, check it works. 6 times 2 is 12. 12, take away 2 is 10, and therefore it works. 7 times 2 is 14, take away 2 is 12, so it works. So we've done the first part. Let's do the second part. 2 structural isomers of C5H8. So first of all, we've got chain and we've got positional. They're structural isomers. We've also got functional group, but they're not going to expect you to understand or know a functional group isomer if they're introducing a new functional group. So let's go for chain or positional. So I'm going to do positional first, and it's currently pent 1 ion, so I am going to draw pent 2 ion. That means, there we go, so that's 1, 2, 3, 4, okay, and 5. And that's pent 2 ion. Notice it's straight, and that's because it's a triple bond, and triple bond has restricted rotation, just like double bonds have. But double bond has 3 things around it, or 3 groups around it, which is 120, trigonal planar. And then this has 2 groups either side, so it makes sense that it's linear, 180 degrees. And that's around these carbons. That's why we draw the straight line. The next one is going to be branching, because if we actually tried to change this to position number 3 and put it as pent 3 ion and put it between these 2 carbons here, you could count 1, 2 here. So pent 3 ion is in fact pent 2 ion. If you're not sure, draw it out yourself and you can see. Then we have to go for the branch. So to do the branch, we'll go back to pent 1 ion. Okay, now that means the ion is at position number 1. If the ion is at position number 1, okay, and we want to branch, we're going to take one of the carbons off. So there's 1, 2, 3, and then 4. And you can see we've done 4 carbons. I need to do a branch, and therefore I'm going to put a branch. The only place I can put a branch, if I put it there, it elongates it. I put it there, it turns it back into this, is to do it here. Okay, so I've got a branch here, and if you name that, that's going to be 3-methyl, so 3-methyl, is that 3, and then it's bute, and it would be 1-ine. Okay, so you've got 2 structural isomers of C5H8. Now let's go on to the last bit, which is the structure of 2,5-dimethyl oct 3-ine. So if that's the case, you will do the stem first, and if you can do it, please do it. Oct, and it's at number 3. So if it's at number 3, I'm going to start 1, then 2. So 1, 2, and this is number 3. This is where my alkyne starts. 1, 2, 3. Okay, so we've done 1, 2, 3, 4, and then 5, 6, and then 7, then last one, and we've got 8. So we've got all the way along 1, 2, 3, 4, 5, 6, 7, 8. Then it says 2,5-dimethyl. So 2 is a methyl and 5 is a methyl. So I've drawn all of that. Now, just to make that clear, I'm just going to get rid of all these numbers so you can see the proper drawing. Okay, and there you go. Okay, and then just tidy that up a little bit there. Okay. Right, so you've got some beautiful pictures, skeletal structures going through the start. We worked out the general formula of the alkyne. We have then gone to 2 structural isomers of C5H8. Okay, because you've got the 5 carbons there. Just to make that clear, there's your 5th one down there. All right, and then we've done 2,5-dimethyl oct 3-ine. And that is how you take a newly introduced functional group and then do numerous questions about it using the information given to you in the table.